So let's take a look at kinematic equation number 4. The number 4 here just being arbitrary. It's just the order that I'm giving them to you. But what we're trying to accomplish with these videos is to derive our kinematic equations intuitively. And as a review, these kinematic equations are just algebraic ways of describing the motion of objects. That's what we're trying to accomplish. So to begin, let's look at this. We're going to look at displacement, beginning with displacement here. So the area under the curve of a velocity time graph gives us displacement. And if we look at the area of this triangle plus the area of this rectangle, then that will describe for us the displacement of an object. And this equation is just a geometric expression of that. 1/2 base times height is the area of a triangle, and base times height is the area of this rectangle. This should be familiar to most of you by now. So let's look at this. This is just continuing what we just did. And what can we do with this? All I'm doing now is just substituting the variables that we use in kinematics for base and height. So displacement's 1/2 base is t, and the height of our triangle is the final velocity minus the initial velocity. The base of our rectangle is t, and the height of our rectangle is the initial velocity. And as I move to the next page, we're going to do a little trick with this. So this is the expression we just looked at, and now it becomes something that suddenly looks different. But it's really not. I have 1/2 t, but what happened here? Well, if you look at these two expressions and remember what we did a little bit earlier, remember this. The acceleration on a velocity time graph is final velocity minus initial velocity, if you remember, divided by time, which was simply the slope formula, right? And if we multiply both sides by t, we get AT equals final velocity minus initial velocity. So what we've done here, since this says those two are equivalent, I've taken final velocity minus initial velocity and substituted AT, because this expression says those two are the same thing. They're equivalent. And then I retained this. So that's why this looks the way it does. And now all I'm going to do is simplify things a little bit. T times t is t squared. So 1/2 t times AT becomes 1/2 AT squared. And now order of operations, I'm just flipping these over to a more conventional expression. So the displacement of an object is 1/2 AT squared plus the initial velocity times time. And as a bonus, some of you may recognize that this expression is also a quadratic equation. And we'll be using that quite a bit in our study of the motion of objects. And there you go. Displacement's 1/2 AT squared plus the initial velocity times time. Kinematic equation number 4.